Welcome to this video on GCSE angle reasoning. Okay, we're going to look at the first question where we have a hexagon and an octagon joined together with an angle X as shown. All right, we've got to find what that is. So the best approach for this, or one approach because there are several, is to find the exterior angles first. Okay. It's really easy to work with the exterior angles. So for the hexagon, this angle in here is 60. Okay, and the reason we can see that is because you've got 6 equal turns of 60 degrees to make in order to make a circle of 360. All right, and this comes therefore from 360 divided by 6. This comes from 360 divided by 8. So it's 45. If you now work out the interior angles, okay, that's always 180 minus the exterior. So the angle on the inside here is 135, okay, and the angle on the inside of the hexagon is 120, okay. That comes from 60 taken away from 180. That comes from 45 taken away from 180. Now you have 3 angles around a point, which add up to 360. So x equals 360. And from that, we take away the 135 and the 120. And that leaves us with an angle of 105 degrees, which is x. Okay, and that's a good answer to that with all the working shown and the reasons provided at the end here. Okay, next question. Several things to do before we can get to x. Let's start by working out this angle here. Okay, and that angle is in a triangle with the other 2 angles given. So I'm going to say that the angle marked as ABD, okay, is equal to 180. Take away the 2 angles I know, 120 and 38. Okay, and if you take all that away from 180, you get left with 22. Okay, and the reason it's 22 is given here. Angles in a triangle add to 180. All right, that's the reason I've used. Okay, we go on to the next thing, which is to mark the 22 on there. And I'm going to state straight away that this angle here is also 22. That's the angle BDC. Okay, but I must give a reason that angle BDC is equal to the angle I've just worked out, ABD, okay, which is equal to 22, okay, and the reason for that is because alternate angles are equal. Okay, now I'm going to work out this one here, and I'm going to do that by saying that angle DEC is going to be on a straight line, you see, with the 41. So angle DEC is going to be 180 minus 41, okay, and that makes 139 degrees. And the reason for that is because angles on a straight line add to 180. All right, so that is 139. And finally, the angle X is in a triangle, yes, with the other 2. So x equals 180, take away the 139 I've just worked out and the 22 to give me 19 degrees. Okay, and the reason for that is given there, angles in a triangle add to 180. Okay, a full answer with a full set of working out and reasoning. Okay, next. several ways we could do this one. I've given a list of possible reasons we could use here. Let's just choose one of them now. Well, I notice we have a triangle, a right angle triangle here, and I know that this angle is going to be 55 in here, okay? And the reason I know that is because it is in a right angle triangle with 35. So I need to write down what I've done, that angle ABQ is equal to 180, take away the right angle, okay, and take away the 35, and that gives me 55, okay, 55 degrees. And the reason for that is that angles in a triangle add up to 180. Okay, that's the first part done. Now, the next thing I could do, the easiest thing, is just to say, well, if that's 55, x is also 55. Okay, it's as simple as that, because that is the same, because it's an alternate angle. So x is the same as angle ABQ, okay, and that's equal to 55 degrees, and the reason I give is because alternate angles are equal. Okay, and that will answer the question fully and properly. Okay, now I could have used other reasons and given other angles. For example, I could have taken the 35, I could have slid it along to here. That's also 35 in there. Okay, and then I would have been using corresponding angles, and I could have then used the fact that these three make a straight line, subtract the 90 and the 35, and that would have given me x that way. But whatever reasons I use must apply to the working I've done. So in this case I used alternate angles to get from ABQ to BQR, which is x. All right. Okay, next question. Parallel lines. Okay, again, lots of different ways we could do this. One way would be to see that there's a straight line here and to work this angle out first by taking it from 180. Okay, so I can say that angle TWZ, so angle TWZ, okay, is equal to 180 minus 126, okay, and that is going to give me 54, okay, 54 degrees, and that is the angle in here, okay, and if that's 54, okay, I could use the fact that x is corresponding with that. That's the quickest way. So I'm going to say that x equals angle TWZ, the one I've just worked out. Okay, and the reason for that is that it's corresponding. All right, so that's also 54 degrees. So let's put the reasons in place. So I've used the fact that angles on a straight line add to 180 for this one, and for the next one I've used the fact that corresponding angles are equal. Okay, now I could have used these reasons instead. I could have said that if that's 54, this one here is 54. Okay, I'll just show you that. That's 54, and if that's 54, because it's vertically opposite, okay, this one is 54 because it's alternate with this one. Okay, that's another set of reasons I could have used, but the reason has to match the working that I've done. So I chose the corresponding angles are equal, and went straight from the 54 straight up to the x. Okay, Next, here we have a diagram not drawn to scale. By the way, none of these diagrams were drawn accurately, and they're not supposed to be, because the idea is you have to work the angles out, not measure them. Okay. Now, we can see it's not drawn accurately because that's supposed to be an isosceles triangle because of these two equal sides, which means these two angles would be the same. So what I'm going to do is I'm just going to put an angle in here, state straight away that that's 65, okay? And the reason I can say that angle BFG, okay, equals 65 is because it's going to be alternate with angle ABF. Okay, so that is equal to ABF, okay, which is alternate. And I'm just going to say that that's because alternate angles are equal. Okay, having established that that's 65, I'm going to say that this one up here is also 65. Okay, and the reason for that is because base angles of an isosceles triangle are equal. So angle FBG, that's what I've just done, angle FBG equals 65 degrees, and the reason for that is here, okay, base angles are equal, and then I've got to work out this angle at the top of the triangle here. Well, I say the top, but it would be if the isosceles triangle was on its base. Okay, and this angle here is going to be angle BGF. Okay, so BGF, and that is going to be equal to 180 degrees, so it's angles in a triangle, minus the other two angles, which are both 65. So it's two lots of 65 from 180, and that's going to give me 130 from 180, which is 50 degrees. Okay, so that's 50 in here. And finally, I've got one more angle to work out, and that is X, and they're on a straight line. So let me just put the reason for that in. That was that the angles in a triangle add up to 180. Okay, and finally, angle X is equal to 180 minus 50, okay, minus 50, which equals 130 degrees. Okay, and the reason for that final part was that the angles on a straight line add to 180 degrees. Okay, so we've used reasons for each bit of the working out. We've shown clearly on the diagram as we worked out the angles what they were, and the working out is very clear and well explained. That's what you need to do to get full marks in these types of questions. Okay, take care.